All right, class, let's do the first try it together. So you've tried this, you've hopefully put in your solution, and hopefully you're right. Let's find out. So you have to begin by graphing each of these equations. Again, they're in slope-intercept form. You're going to find the slope. Nope, sorry, you're going to find the y-intercept first. Your y-intercept, which we use the letter B for, is -2. So you graph your y-intercept first. So your y-intercept is -2. So go to the origin at 0, 0, and go down and put a dot right here. I'm going to put a couple dots so you can see it in red. There's my y-intercept. Then I use my slope. For this first equation, y equals 1/2 x minus 2, the slope here is 1/2. So my slope, m, is equal to 1/2. So that means I'm going to run 2, go up 1. Run 2, go up 1. You see me plotting these points. I can make them a little darker. It's supposed to be a single point. Maybe let's do this. Let's make it a little fatter. There. That'll be better. Now we can see those points. So we are going to run 2, go up 1, and there's another point. Now we can, because it's both positive, we can go in the reverse direction. We can run 2, go down 1 if we wanted to go backwards. But anyway, there's enough of that first line. Now we're going to plot the second line. I'm going to do that in blue. So I've changed here. I got to find my y-intercept, or my b value, which is -7. So I'm going to note that this is y equals mx plus b. So my y-intercept, this is my b value. Remember, the equation looks like this: y equals mx plus b. So we're looking for the variable value, b, right here, which is -7. So now you're going to find -7. So down here is, right here, I'm going to put a point. I'm going to make it a little thicker. That is my y-intercept. Now I'm going to use my slope. For this particular problem, the second line, the slope is 3. So I'm going to write out my slope for the second line. M is equal to 3. But 3 is understood to be 3 over 1. So I'm going to run 1, rise 3. So from my y-intercept down here, I'm going to run over 3. 1, 2, 3, go up 1, and I get a point. And again, and make that point thicker. There we go. Now I need more points, don't I? So I'm going to run over 1. Oops, I messed up. Let's erase that. That's not the right point. So I'm going to run 1. You guys might be doing this too. Run 1, go up 3. Let's make it thicker. Run 1, go up 3. Good. Run 1, go up 3. Bam, I think we just had an intersection, didn't we? So run 1, go up 3. Run 1, go up 3. We have another line. So we can see then that we have an intersection here at 2, -1. So I could draw in this line if I wanted to. Maybe make the other line a little thinner. The other line's right here. You can see this point of intersection right there. That's the solution where the lines intersect. That solution is 2, -1. So you can always check your solution to see if you're right by plugging in that solution to both equations. Both equations should be true. I'm going to do a quick check. I'll do the check in green today. So we're going to check equation 1, which is y is equal to 1/2 x minus 2. And if you plug that in, that ordered pair, you should get the right answer. So y is -1 times 1/2. Your x was 2. Multiply by 2 minus 2. Does the left side equal the right side when you do this? So you get -1. 1/2 of 2 is actually 1 minus 2. So you get -1 is equal to -1. Check. That is true. So it does appear that we have the right solution as the ordered pair, the point of intersection, 2, -1. Plug it in and double check that it also works in the second equation. You'll find that it does.